So I'm going to go over some more examples of finding confidence intervals, but this time for an unknown population standard deviation. And then we'll talk about solving for a sample size. So our first example says for a group of 35 random men subjected to a stressful situation, the mean number of heartbeats per minute of the sample was 126 and the standard deviation was 4. Find the 95% confidence interval of the true mean. So the formula for calculating the confidence interval for an unknown population standard deviation is x bar plus or minus a t critical value times the sample standard deviation divided by the square root of n. So with t's critical values, we have to first identify something called degrees of freedom, which is always your n minus 1. Which in this case, n is 35, which when we subtract 1 gives us 34. We now use our table to see where 95% confidence level lines up with a degree of freedom of 34, which our table, once we get to 30, just goes up by tens. So we'll use 30, and we get a t critical value of 2.042. Now we're going to plug in our values into our formula. So our mean is 126 plus or minus 2.042 times the sample standard deviation of 4 divided by the square root of n, which is 35. So we get 126 plus or minus 1.381. And when we subtract, we get a lower value of 124.619. And when we add it, we get an upper value of 127.381. So for interpreting what this confidence interval means, we can say with 95% confidence, the average number of heartbeats for all men is between, and we can round to whole numbers here, 125 and 127. Our next question asks us, what is the mean number of hours slept by a high school student using our class construct a 90% confidence interval for the population mean? So using all of the statistics students, we have our list of average hours of sleep. Now, we don't quite have 30 students here. So we're just going to assume our distribution is normal. And then I'm going to go ahead and construct a dot plot just so we can see what our distribution looks like. So plotting all of our values. And then if I were to draw the curve that went with it, it's kind of got a curve to it, but not really, because again, we only have 16 in our sample size, which is a bit on the small side. Next, what we need to do is calculate our mean and our sample standard deviation. So using the calculator, we get a mean of 6.88 and a sample standard deviation of 1.9. Our degrees of freedom is going to be 15 because we have a sample size of 16. which means we're going to have a t critical value of 1.753, which again we find by seeing where 90% confidence level and our degrees of 15 meet in our table. Now we can use our formula for unknown population standard deviation. Our mean is 6.88 plus or minus our t critical value 1.753 times our sample standard deviation 1.9 divided by the square root of n, which is 16. So we're going to have 6.88 plus or minus 0.824. Subtracting gives us a lower value of 6.056, and adding gives us an upper value of 7.704. So interpreting our confidence interval, we can say with 90% confidence, the average number of hours slept by all high school students is between, I'm going to round one decimal place here, 6.1 and 7.7 hours. So in our last example, we are given that a random sample of 45 shoppers found they spend an average of $127.80 at the store with a standard deviation of $8.50. Find and interpret the 99% confidence interval for the mean amount spent by all shoppers. So we're going to start by identifying our degrees of freedom, which is going to be 44. So we can find our t value. And 44 is not in our table, so we're going to use 40. So 99% and 40 meet at 2.704. So we'll take our mean, 127.80, plus or minus 2.704 times our sample standard deviation of 8.5 divided by the square root of n, which is 45. So we're going to have 127.80 plus or minus, and then we're only going to round 2 decimal places here because we are talking about money, and money only has 2 decimal places, so it'll be plus or minus 3.43, which gives us a confidence interval of 124.37 to 131.23. So interpreting our confidence interval, we can say with 99% confidence, the average amount of money spent by all shoppers is between 124.37 and 131.23. So in case you didn't notice, on this example and the last example, I did include units when I was writing up the interpretation. And it is important that when you're writing your interpretation, if you know units, you want to include them when you're writing your sentence. So the last thing we're going to talk about is finding sample size. So just like we did with proportions, we can also find a desired sample size to give a certain margin of error. And the process is similar, but we'll instead use the margin of error formula for means. So the margin of error formula for a mean is our z critical score times our population standard deviation divided by the square root of n. Okay. We will need a population standard deviation or an estimate of it to find sample size, so we can use our z critical value instead of a t critical value. And the reason being is that t critical values depend on a known sample size. And since we're solving for sample size, we can't use a t critical value. So if I take that formula and I solve for n, we end up with n equals the population standard deviation times our z critical value divided by the margin of error squared. So we're going to use that in our example. So we know the margin of error for an 80% confidence interval for the mean amount of time studying for an exam needs to be 0.5 hours. We also know the population standard deviation is 1.7 hours from our previous study. What size sample should be selected to have the desired margin of error? So using our formula, we have n equals, and then our population standard deviation, 1.7, times, and then our z critical value for an 80% confidence interval is 1.282, divided by our margin of error, 0.5, and then we'll square it. So we're going to get an n of 18.999, which we will round up to the nearest whole number. So we'll have 19 people in our sample. Okay. Our sample size is a bit smaller here than what we normally see, and that's because our margin of error was so large. Our margin of error was 0.5, which is a very large margin of error, which means you need a smaller sample size if you're going to have that large of a margin of error. If you have any questions over the part 2 or part 1 of the notes, please let me know.